Welcome to the session. In this video, we will see how to create an Azure Container Registry and a container instance using ARM templates and Azure DevOps. And then, we will create a Node.js Docker image and push it to the Azure Container instance. I will give you a brief description about the video. First, we will download the source code from the Git, which contains our ARM templates and the source code for Docker image. Next, we will explore the web API using Node with Express and push it into a Docker image. Then, we will push the source code to Azure DevOps. After that, we create a build pipeline, where we will be adding tasks for copying the ARM templates in the source code folder. And finally, push the artifacts to the drop folder. Next, we will create a release pipeline, where we will get the ARM templates from the artifacts and create the Azure Container Registry. Just after creating the ACR, we have to read the container registry name, server name and password. Then we'll build the Docker using the docker build command and push the Docker image to the Azure Container Registry. As a final step, it will create the Azure Container instance using the ARM template and then push the Docker image to the container instance. Eventually, we will verify the Azure environment, where we can see the container registry and our container instance. Consequently, we'll see the output in a browser. So let's get started. And now, we are going to set up the source codes in our local system. As a first step, we can download the entire source code from the Git repository. Git repository URL is mentioned below in the description. Go to the Git repo and download it as a zip file. Do not clone this repo to your local system, because we are going to push this source code in Azure Repo. Let's understand what is inside the source code. Open the source code in VS Code Editor. First, we can go through the ARM template folder. Our aim is to create two resources in Azure. First one is an Azure Container Instance, and the second one is Azure Container Registry. Let's see the container registry.azrm.json file. Later in the session, Azure Release Pipeline will create the container registry using this script. Let's dig into this file. Registry name, we can give with our choice. Also, I am appending my container registry name with the deployment ID. Using this deployment ID along with the name, we'll give a distinct resource name for each resource group Azure. Resource group name and location will be given as pipeline variables. This will be discussed later on in this series. Here I used the standard SKU. This output parameter part is very important. Here we are defining how to get the newly created Azure Container Registry name, server name, username and password. This output data can be read in the next release pipeline job and can set it as a pipeline variable. Next file is containerinstance.azmr.json. This file is the ARM template for Azure Container Instance. Here we require few parameters which can be different for different releases. For example, we deploy on build to dev, and the same can be deployed to production with different configuration values. These configuration values can be passed as parameters to the ARM template while we are in the release pipeline. While doing deployment to different environments, we cannot change the code specific to each environment. If we use the changing values as parameters, we can deploy our same build to multiple environments with different parameter values. Here, we are creating the container instance with following parameters. First one is number of CPUs. So, when you are deploying it to a dev environment, we may be using a single core. But the same application is deploying to production maybe with 4 cores. Next is memory and GBs of the container instance which we will be creating in our release pipeline. Registry server name, registry username, registry password are reading from the container registry ARM template output variable and not by us. And the last file in the ARM template folder is the param.containerinstances.json file. This file defines the input parameters we are passing to the container instance ARM template. Here, we need to mention which are the parameters and optionally we can give its default values. If we are not providing the default values, this should be provided in the release pipeline. Image value is coming from container registry. We will see how all these files are integrating while dealing with release pipeline. Next is our Docker file, which will create the Docker image for our Node application. Later on, this image is pushed to the container registry and then will be deployed to the container instance. Docker file will be explained in the next session in detail. But in high level, we are creating a Node server image and deploying our Node with Express application. Index.js file is a Node file which exposes 2 endpoints using Express. First one is a get and will return a hello world text. And the second one is /customers. Next file is package.json. We can exclude MongoDB, Monk, Noddaman, and Socket.io modules as they are not using in our project. Main node module we are using here is Express for Node. Express is a minimal and flexible Node.js web application framework that provides a robust set of features to develop web and mobile applications. And we are going to create the Docker image in the local system and run it on the 3000 port. Open the Docker file which is inside the source code folder. Now, to run the Docker image in your local system, first you have to install Docker in your system. Once Docker is installed in your system, open the readme.md file, where I mention how we can run the Docker file in your local system. As I am using Ubuntu operating system, I will use sudo as prefix to get admin access. If you are running the same on a Windows system, this sudo command is not required. First we want to run the npm install and see it's all working. For that, open the control terminal and direct to the right folder. Now you can run npm install. This will create a node module folder in the project and download all the node modules mentioned in the package.json. You can run this index.json file using npm start command. Anyway, we are going to run this inside the Docker image now. Copy the second command from the readme.md file. This is to build the Docker image on your local system. After -t you can give your own Docker image name. Also you can give a version after the name. And the final dot stands for the current folder. Docker finds the file in the directory with the name Docker file in the current directory and executes it. As mentioned in our Docker file, it downloads the node server and create an image in the local system. Then it sets the current working directory to user/src/app. In the next step, when we say /, it takes the app folder as current folder. Then, copy package.json file inside the Docker image. Now it executes the run npm install command inside the Docker image. This will create the node module folder inside our Docker image. Next step is to copy all the other files to the app folder. Then, set the application to run on 8080 port. And finally, we are executing the index.js file using node command. This will execute the file while the Docker image is running. Now, to see the images which are running in the Docker, we can use the command docker images. This will list all the images which are there in the system. We can see the image which we created just now. Following step is to run our Docker image in our system by executing the next command. This will run the Docker on 3000 port. -d stands for detached mode. Now open the browser and we can check the application running on the port 3000. Here you go. The return value is hello world. Okay, now we are done. The Docker image is running on our local PC. We are going to push our local files to the Azure Remote repo. To push your source code to Azure Repo, first we should register to devops.azure.com site. Azure DevOps Server is a Microsoft product that provides version control, reporting, requirements management, project management, automated builds, lab management, testing and release management capabilities. It covers the entire application lifecycle and enables DevOps capabilities. Here we are going to use Azure DevOps as a repo, and then we'll deploy it to Azure using the build and release pipeline. Under one organization, we can have multiple projects. And under one project, we can have multiple repos. Let's create a new project named ACI with ARM. Now we can see the repo is empty. Here, they are providing the commands how to clone or push an existing repo using command line. Let's push the code using CMD. We can directly go to the right path by just typing the CMD on the address bar. Here we can see we are inside our project folder. Now we can initiate our folder to Azure Repo by typing git init. The git init command creates a new Git repository in our local folder, and we are currently there. We can check the status of the folder by typing git status command. This is telling that there are 2 untracked folders. By using git add command, we will be able to add these files and folders to our local Git repository. For that, we can enter git add then a dot. We can see here, all the files are adding to the local repository. Now we can commit our source code to our local repository using git commit -m, then the comments. This will commit our source code to our local system. Still, our source code is in our local repository only. Next step is to push our local repository files to the remote Azure repository. To do so, we can use git push command. Azure provides the push commands to push to a remote Azure repo for the first time. So, copy the push command from the Azure repo, which is defining where our remote repo is, and push all our local commits to the remote origin. By default, it will push our source code to the master branch. This will prompt the Azure verification page, where you want to log in with your credentials. From second time onwards, you just want to use git push command to push all your commits to the remote repository. Now let's see whether our files are pushed to Azure Repo or not. Here you go. All your files are there in the remote repo, and now we are going to create the build pipeline and generate the artifacts. We can use the classic editor without using the YAML files. Our source code is present in our Azure Repo Git. So, we can choose the first option here. Select the project, repo and branch and then continue. Let's take an empty job. We will not get any build-in templates as we are doing all these custom deployments. Choose the agent specification to Ubuntu because we are going to use our Ubuntu Docker image. Now we can add tasks to our agent job one by one. First we need to do is, we will copy and keep the ARM template files for release. Secondly, copy our source code folder and keep it for release pipeline. And third and the final step is to push the artifacts for release. We can combine our first and second options if needed. But in many cases, these two folders may not be in the same directory. Or there may be many other directories present in the same directory. That is the reason why I am keeping two different tasks, one for ARM template folder to copy and the other one for source code folder. Let's add the first task to the agent job. Search for a task, copy files task and add it to the agent jobs. Change the job name to copy ARM template. So, we can easily understand what this job is going to do. In the copy file task, the first option to choose from where your source file or folder is. We can click on the three dots, which will open a modal pop-up where we can choose the file from our branch repository. Our files are present in the ARM template folder. So let's select it. Next field is to mention what all contents are to be added into the artifacts. We need to copy all the files in the ARM template folder. Next field is the target folder. This states that where we need to store our copied files. We can use the build and pipeline variables as the root folder, and then we can keep another folder with the name ARM templates. This will keep the target folder also similar to our source folder. Now let's add our source code folder to the artifacts folder. Choose the task file copy job for this too. We can name the task as copy source code. Choose the source code folder, similar to how we did for ARM templates. Click on the three dots and select the source code folder. Keep all contents. No changes required. Next field is target, where we can keep the root folder / source code, same folder structure as our source folder. Now let's add the final job for the build pipeline, which is nothing but the push build artifacts. Reason to push the files into artifacts is, when we are in the release pipeline, we will not have access to the repository. So, we need to keep all the required files in the artifacts. Each build will have its own build number, and we can release those builds to any stages. Stages are like dev, prod, etc. In push artifacts job, we don't require to make any changes. Change our build pipeline name to whatever we want. Now let's save and queue. It's good to build one time before we set up our release pipeline so that we can easily refer our artifacts file. One more thing, which we can do in build pipeline, is to enable continuous integration trigger. So that, whenever there is a change in the source code like our node application changes or ARM template changes, it automatically deploy the modifications to Azure. Okay, we'll see the pipeline history. Cool, our build is in progress. Let's go and see the build, which is running. build is completed very fast and we can see our artifacts. We can see the artifacts here as well. Here, we can see our ARM templates and source codes are kept inside the drop folder which can be used in our release pipeline. We are going to create the release pipeline. In this session, first we will be creating the container registry. Then we will build and push our container image to the container registry. And finally we will create our container instance and deploy our Docker image from container registry to it. In Azure, by default, they won't allow the release pipelines to create container registry and container instance. We have to explicitly include them to the resource providers list. Let's do it. Open Azure portal and direct to all services and open subscriptions. Choose the right subscription. Under the subscription, select the resource providers. Now search for Microsoft Container Registry and Container Instance. I have already registered them in my Azure account. That is the reason why I can see them as registered. If it is not registered, we can select one by one and click the register button on the top. See, when I click the container service, the register icon is enabled. Anyway, container service is not required for us now. Also, it may take a couple of minutes to get it registered. Now move to the release pipeline. Here, we don't want to use any existing templates. Let's pick the empty job. Let me name this stage as dev. Similarly, we can have multiple stages configured in release pipeline. For example, we can create pre-prod, prod, etc. Once we create one build, we can release that build to any stage. Also, certain rules can be set like move the build to prod only when we release it to pre-prod. Now we can choose artifacts. This states that from where we are getting the artifacts. We can choose it from build. In the source dropdown, we can select our build pipeline name. This will automatically set the default version and the source alias. Let's click the add button. Now we can enable our continuous deployment trigger. So, whenever there is a build completed, release will automatically get triggered. Next we can set our pipeline variables. For the ARM template deployment, we require resource group name and in location. Instead of writing in each task, we can define it here as a variable, and we can use this variable in the tasks. First let's add resource group name and then resource group location. Location, let's give it East US. So, all our resources, which are using this variable will create at the same location. Let's give our resource group name as ACI test. ACI stands for Azure Container Instance. If the resource group already exists, this ARM template will create the new resources inside that resource group. Else, it will create a resource group with that name. As we didn't create any resource group in Azure, this will automatically create the resource group for us. Second time onwards, it will just do the incremental changes. However, increasing the CPU and memory won't work with the ARM template incremental changes. For that, we have to drop the existing container instance and run this job to create a new resource. Let's save it so that we don't lose our changes. Before moving further, let's change our agent to Ubuntu. This is because we are building the Docker for Node Ubuntu version. Next, we will start adding our agent jobs. First we will deploy our Azure Container Registry to Azure using ARM template. For that, we can add the Azure template deployment task. Display name we can change to something which we can understand by seeing the name itself. So we can give the name ARM template deployment ACR. Next we need to set our Azure Resource Manager connection. For that, click on the Manage link and that will redirect you to the Service Connection page, where you can add external services to the Azure DevOps. Select the Azure Resource Manager option and then choose the service principal. Next, we can select subscription level and choose our subscription, where it will prompt you to enter your Azure credentials. Then save the connection name, let's say, pay as you go. Now back to our release pipeline tab. Here we can see the newly added subscription appearing here. While selecting it, we may have to provide the Azure credentials once more. Now you can choose the subscription also in the next drop-down list. Action: you can keep the same create or update resource group. For the resource group, we have already given the variable, so we can use that one. For the location also, we should use the variable which we have already created. Using these variables, we will get the flexibility to change the location and resource group at any time. Next step is to choose our ARM template file. Click on the three dots, which will show our artifacts folder, where we have already kept our ARM templates and Node.js codes. Choose the container registry.azrm.json file. We don't have any template parameters and override template parameters for ACR creation. Deployment mode, we can keep the same, incremental. Give a deployment name, get resource names _ release.release name. Deployment output is very important here. Let's name it deployment output. The reason for adding the deployment output value is we require to get the newly created ACR name, server name, username and password. You must be remembering that while we created the ACR ARM template, we have mentioned one output section where we mentioned these name, server name, username and password. We require those values while we create and push the Docker image to ACR. Also, we require the server name when we create the ACI. If we were using the Windows agent pool, next step would have been a really simple step. Because we are using Ubuntu, we cannot use Azure Resource Manager Deployment Output Parser task. Azure Resource Manager Deployment Output Parser task will only work on Windows agent. So after a lot of trial and error, I figured it out. We can read the ARM template output variable into a pipeline variable. Using the PowerShell script, we will be able to achieve the same action. Also make sure that the PowerShell script version should be 2. Else the script won't run on Ubuntu. Let's name the task to read output. Make it to inline script. Again, it was really a tough job for me to find out how the script can set the output values into a pipeline variables. If we are using Windows agent, it is easy to set the values into a pipeline variable. I have given those scripts below in the description so that you can just copy paste and add your variables there. Here you can see I have assigned the output variable to a local variable $var. Now $var.registry_name.value will get the registry name which we mentioned in our ACR ARM template. Similarly, we can get server name, username and password. To check the values, we can use echo command and that will print the values while we execute our job. Next major step is to keep those variables into a pipeline variable. Now you can just blindly follow the code. One important thing is, you have to specify the variable name in capital letter, else it won't work in Ubuntu. It took me almost a day to get this output variable and set it in a pipeline variable. Let's put the script in the script section. Now we are all set to read those registry details in any other following tasks. Our next step is to build our Docker image. So let's search for the task, Docker. Add it to the agent job. Name it to build an image. Change the task version to 0.*. Container registry type, no need to change, keep it as Azure Container Registry. Choose your Azure subscription which we added few minutes back. Next we can fill the container registry. Instead of writing just container registry name, mention it with the following text. We just want to update the subscription ID just after subscription/. I have mentioned this script below in the description. Action, keep it build an image. Next is to choose the Docker file. Click on the 3 dots and choose the exact Docker file from the build repository. This time it is inside the source folder. */Docker file also would have worked, but in case, if we have two Docker files present in different folders there will be issues. So it is preferable to choose the right Docker file manually. This will create the image with the following name. Next step, we will push the image to the ACR. For that we need to add one more Docker task. We can change the display name to push an image. Subscription, we can keep the same Azure one. Copy the same text for Azure Container Registry. Action, we can change to push an image. Image name, we can keep as it is. If you have changed earlier the image name, you can put that image name here. And finally we can add our step to create our ACI. For that choose ARM template deployment. Change the name to ARM template deployment ACI. Azure Resource Manager connection, we can choose the same Azure connection. Subscription also, the same Azure connection. Action, create or update resource group. Resource group and location, we can use the pipeline variable. For template, choose the 3 dots and select the container instance.azmr.json. Next is template parameters. Click on the 3 dots and select the param.containeerinstance.azmr.json. Finally, we can choose the override template parameters. If we didn't give any value, here it will take all the default values from our params file. Let's give few override values, which are ACR details, which we created in the first step of our release pipeline. I will mention this details in the description. This details contains the container registry server name, username, password and the registry server name. Also as a parameter, I have mentioned one environment name, which will add as an environment variable to the Docker container. Let's save the release pipeline. Now it's time for action. We can try to run the build pipeline and see if the container registry and container instances are creating in the Azure or not. Build pipeline runs and all the steps are success. We can see one artifact is created. As expected, all the files are included in the artifacts folder. And yes, we can see, the release pipeline is already triggered. Let's see what is going on. It will take some time, because it is creating the resources one by one. As defined, it will first create the Azure Container Registry. Then build the Docker image and push that image to the container registry. Finally, we can see the container instance task also running. Let's see the Azure instances of ACR and ACI are created. Yes, both are created. First, we can check the container registry. We can see one Docker image is already created here. Each build will create the new tags of images inside the container instance. But if we run only the release pipeline multiple times or releases it to multiple stages, it won't create new tags. This is because we are using the same source code while multiple release. Next, let's have a look at the container instance. Yes, it's running already. Check the properties, we can see it is using one core with 4 GB memory. Also the environment variable, which we have added. Even, we can see the logs, which we are writing to the console. Let's access the URL and see if we can access it from outside. Now we can delete the resources. Else it will charge you more. Delete the resource group, so all the components inside will be deleted automatically. Okay guys. That's the end of this series. Thanks for watching. More exciting topics are on the way. Stay tuned.